In our last video, we understood what happens when a current-carrying conductor is placed in a magnetic field. We also understood Fleming's left-hand rule and the working principle of electric motor and its applications like fan, refrigerator, computer and washing machine. All these equipments work on electricity. Have you ever thought about how we generate electricity? Electricity is generated by an electric generator. An electric generator works on the principle of electromagnetic induction. We have heard of electromagnets, but what does electromagnetic induction mean? Let's understand electromagnetic induction with the help of this activity. To perform this activity, we need a coil of wire having 50 number of turns, a power magnet and a galvanometer. What is galvanometer? Galvanometer is a device which is used to detect the presence of current in the circuit. After connecting the galvanometer in the circuit in this fashion, take the north pole of the magnet near the coil. Then a deflection in the galvanometer's needle can be seen in the direction. Let us assume that deflection is on the right side. Deflection in the needle proves that there is electric current in the coil. This needle comes back to zero as soon as the motion of the magnet stops. In the same way, if we withdraw the north pole away from the coil, then deflection in the opposite side can be seen in the needle, which shows the current is flowing in the opposite direction in the circuit. In the second case, we keep the magnet stationary and move one end of the coil towards the north pole of the magnet. Then the needle will show the deflection on the right hand side and will show deflection on the left side if we move coil away from the magnet. In the third case, if we move the south pole of the magnet towards the coil, then the deflection will be opposite than it was in case 1. So we can infer from this activity that when coil and magnet both are stationary, then there is no deflection in the galvanometer. The motion of the coil or magnet induces a potential difference which sets up an induced electric current in the circuit. Let's take this activity one step ahead. Here replace the magnet with another current-carrying coil having 100 number of turns. We can hold the two coils with the help of a hollow cylinder of cardboard. When we put on the switch after connecting the coil 1 with the battery, then a momentary deflection can be seen in the needle of the galvanometer in one direction, and the needle jumps back to zero quickly. If we put off the switch, then as well a deflection can be seen but in the opposite direction. If the direction of the current in coil 1 is reversed and the switch is on, then as well a deflection can be seen in the needle of the galvanometer but in the opposite direction. So we can infer from this activity that when the current is flowing at the constant rate in the coil 1, then there is no effect on the galvanometer connected with the coil 2. When the electric current changes in the coil 1, then in coil 2, a potential difference is induced. Coil 1 is known as the primary coil and coil 2 is known as a secondary coil. There is a change in the magnetic field around coil 1 when the current changes. Due to this, the magnetic field of the secondary coil also changes, which induces an electric current in the circuit. The process by which a changing magnetic field in a conductor induces current in another conductor is known as electromagnetic induction. Michael Faraday experienced this for the first time in history. To find the direction of this induced current, Fleming's right-hand rule is being used. This rule states that if the index finger, middle finger and thumb of the right hand stretched so that all the three are mutually perpendicular to each other, then index finger will represent the direction of magnetic field lines, thumb will represent the direction of the motion, then the middle finger will give the direction of the induced current. As Fleming's left-hand rule tells the direction of the force acted due to the electric current and magnetic field, conversely Fleming's right-hand rule gives the direction of the induced current when a conductor is placed in a changing magnetic field. In the upcoming video, we'll understand the working of an electric generator, which is an application of electromagnetic induction.